Before we open our phone charger, how does a phone charger works? A phone charger is very similar to a power supply. It converts your AC from your city power lines and convert it into an acceptable DC voltage for your phone. Old and cheap charger uses the same style as a conventional power supply, but modern chargers now uses the same style as a switch mode power supply. Some charger companies has also already moved into using gallium nitride chargers, which is exponentially more efficient than silicon tech chargers. Just like a switch mode power supply, most modern chargers would contain an AC input, rectifier, capacitor, transistor, pulse width modulator, transformer, secondary rectifier, secondary capacitor, voltage regulator, and a USB port. The AC input will allow you to connect your charger to the outlet and provide alternating current. The rectifier then converts the AC wave into DC pulse. The capacitor now smoothens the DC pulse from the rectifier. The pulse width modulator generates a very high frequency DC pulse and sends it into the transistor to use the DC from the capacitor and turn it into a DC pulse with the same frequency from the pulse width modulator. The transformer then turns the DC pulse into an AC wave and decreases the voltage of the AC. Again, the rectifier turns it back into the DC pulse and the capacitor smoothens the DC pulse. The voltage regulator then prevents the DC voltage from getting higher or lower than 5 volts before reaching the USB port. Most modern quick chargers also has a quick charge protocol. Unlike old chargers which only provides only 5 volts and a certain current, Quick Charge Protocol checks your device whether it is capable of charging using higher voltage, such as 9 volts, 12 volts, and above 15 volts. Quick Charge Protocol also communicates with the BMS of your device to check how much current is your phone capable. There are also other non-standardized way of charging, just like Xiaomi's 120 watt Hypercharge on the Xiaomi Mi 11T. There are also other prototype charging like Xiaomi 200 watts Hypercharge and Oppo's SuperVOOC 240 watt charging. Because of these charging speeds, these chargers uses a USB-C as its port since USB-A isn't capable of allowing enough current or voltage to pass through without breaking the cable. Though the charging speed mostly relies on your charger, it will also be affected by the limitation of your cable that you have and the maximum charging speed limitation of your device. The first phone charger is a MyPhone power adapter with a 5V and 1A output. In testing the first charger, it doesn't respond with any voltage. Generally, zero voltage means a component is completely shorted. To open the charger, it's practically the same way as opening a remote. Find a slit to push the pry tool. Gently push the cover sideways until the clip is out. After removing the cover, everything should now be easy to remove. After inspecting the board, I found that a diode is completely shorted. The diode was a 1N4007 and can be easily replaceable. To remove the diode, I used a soldering iron and a soldering paste to melt the lead faster and pulled the diode using tweezers. I then used the same type of diode, 1N4007, with the same size to replace it. I cleaned the board using solder wick to remove the leftover solder to be able to easily place the diode in place. I used a soldering iron and soldering lead to connect the diode to the circuit, and cut off the excess wire from the diode using wire cutter. After repairing it, we can now reassemble it. Just simply place the components back and clip the cover back to the case. After retesting the charger, we can see that the charger now works and has an output of 5.3 volts. The second phone charger is a ZTE adapter with a 5V and 0.7A output. The charger cannot be tested because the damaged component is the USB port itself. To begin replacing it, this charger can easily be dismantled as the adhesive of the charger is not very hard. Just simply pull the components out. To replace the USB port, I took the USB port of a different circuit. I tried to use the solder wick to remove the excess solder and used the same method as last time. Melt the lid and pull it using tweezers. Going back to our circuit again, same method. Melt and pull. After removing the USB port, I cleaned the board via solder wick, soldering iron, alcohol, and tissue. Once the board is clean, I can simply push the other USB port and solder it. To reassemble the charger back, simply place the board back on one half of the case and close it with the other one. In retesting the charger, I managed to get a 4.5V output, which is close to 5V. The last charger is a Cherry Mobile travel charger which can only output 5V and 0.6A. In testing, this charger has no problem in any way, shape, or form. It still managed to output a 4.9V on its USB port. This charger can't easily be opened without any damage, so I opened it by brute force. I also checked behind the sticker whether it has any screw, but it didn't have any way. In terms of repairing this charger without damaging its case, if it is broken, it's practically impossible, unless if you can 3D print an exact copy of its case. Modern chargers aren't designed to be opened just like this charger. Most chargers nowadays have the clips inside of the charger or used a very strong glue, which makes it impossible to open without breaking it. When you try to search how to open a charger, you may also find that it is possible to open it via petrol gas. But if it's not obvious enough, it's just a massive hazard to even place petrol near a device that heats up just like a charger. So even if you manage to open it, the charger itself will be a fire hazard and an explosive hazard.